Hello students, in this class we are going to learn about chromatography and one of its type, that is ion exchange chromatography in brief. Before that we will see what is chromatography. Chromatography is a biochemical technique in which the components of a mixture are separated based on their different migration. In this method, we separate various biomolecules such as fatty acids, amino acids, carbohydrates, etc. are separated and identified. Chromatography is an important technique that enables the separation, identification and purification of the components of a mixture for qualitative and quantitative analysis. The term was first coined by Michael Twitt in 1906. Chromatography is a Greek word. Chromat means color and graphing means to write. Chromatographic procedures make use of difference in size, binding affinities, charge and other properties to separate materials. Chromatography is the only method which is used to separate simple component from complex mixtures. Types of chromatography. There are 6 types of chromatography. They are paper chromatography, thin layer chromatography, column chromatography, gas chromatography, ion exchange chromatography, high performance liquid chromatography. In this class, we are going to see ion exchange chromatography in brief. The ion exchange chromatography is used to separate charged particles or polar molecules. Based on their affinity, it is separated. It depends on the pH of the analyte. The analyte is nothing but the sample to be separated. This technique is used to separate the charged particles. In all the chromatography, 3 important components are there. They are stationary phase, analyte and mobile phase. But the materials used will vary according to types of chromatography. The first component is stationary phase. The stationary phase is stable and which interact with the molecule and the sample to be separated. Already you know that in ion exchange chromatography, the charged particles are separated. The second component is analyte. Analyte is nothing but the sample to be separated. The separated sample is called the analyte. The third component is mobile phase. It is a movable part which helps the analyte to interact with the stationary phase. In mobile phase, we use buffer. If we separate positive ions, we use tris buffer. If we separate negative ions, we use acetate and phosphate buffer. In ion exchange chromatography, the stationary phase consists of column matrix and fixed ions. The fixed ions play an important role. Due to the fixed ions, we classify into 2 types. One is cation exchange chromatography, the other one is anion exchange chromatography. In cation exchange chromatography is used to separate positive ions. You know that opposite charges are attractive to each other. The cations are positive, so we add negatively charged fixed ions. The fixed ions are carboxyl, carboxyl methyl, sulfo, sulfomethyl, etc. In anion exchange chromatography is used to separate negative ions. The anions are negative charge, so we add positively charged fixed ions. That is diethyl aminoethyl. Isoelectric point. The isoelectric point is the pH at which a molecule carries no net electrical charge. It is denoted as ID. Based on the pH, it is in 3 forms: positively charged, negatively charged and neutral charged. If the pH is lesser than the isoelectric point, it is positively charged. If the pH is higher than the isoelectric point, it is negatively charged. If we separate a molecule, either it can be positive or negative charge, but the pH is neutral, so the net charge is 0. That pH we call it as isoelectric point. It is also called Zwitter ion. There are 4 stages are there. One is conditioning, loading, washing and elution. First, we charging the column. The stationary phase is cellulose matrix in addition of fixed ions. If we separate positive charge, we have applied negative charge molecule so that the positive charge attach with negatively charged particles and the positive ions are separated. The second stage is loading. Here we add sample along with the running buffer. In the column, cellulose matrix and fixed ions are present. If we load the sample along with the buffer, the sample may be positive, negative or neutral. The positive charge ion is react with the negative charge ion and move slowly because the opposite charge is attractive. But the negative charge and the neutral charge, it moves fastly. In some places, the neutral charge will attach. After the washing stage, the neutral charge will release. The unbound sample is removed by washing. The fourth stage is elution. We can change the buffer pH. So, the pH is changed. The charge of the analyte is also changed. We can separate the sample easily. If the attached particle is positive, we increase the pH level. So, it converts into negative charge, so it is easily washed out. If the attached particle is negative, we decrease the pH level, so it converts into positive charge and it is washed out. Advantages. Some smaller molecules are separated. Protein and other charged biomolecules are easily separated. Inorganic ions are also separated. It is the most efficient method for the separation of charged particles. Thank you.